My name is Fred West. I am a professor at the University of Alberta, which is in Edmonton in Canada. Well, I'm a synthetic organic chemist, so that means what I concern myself with is trying to find the best way to make molecules in the laboratory. So we call that chemical synthesis, and in many cases, the kinds of molecules we want to make are natural compounds, or maybe some very close, similar structure to a natural compound that has some important medical properties, for example. And for one reason or another, we want to make them in the lab, maybe because we think we can make them better, or maybe just because we want to learn from the challenge of making these molecules. And then sort of associated with that is we sometimes find that we can imagine a really good way to make this molecule, but the reaction that we need doesn't exist. And so then the other part of what we do is we try to invent new reactions, new chemical reactions that we think will be very useful, not just for us, but to other synthetic chemists, to transform one molecule into another one. So that's sort of our main activities. There's kind of two things that we do. One thing is we discover knowledge, and the other thing that we do is we train people. And I would say both of those things are equally important, and they have different ways of generating excitement. So I'll talk about knowledge first. I'll just say that probably the thing that I find most exciting is when things don't work the way we expected and we get a big surprise. Sometimes it's a bad surprise, or at least we think it's bad, but what we quickly find out is we don't understand things as well as we thought we did, and that is an opportunity to explore new directions. So it's like you've stumbled across something that nobody else knew about, that you have the opportunity to decide how you're going to explore this new phenomenon. So with students, I often find that they interpret a bad or an unsuccessful experiment always as a bad result, and I have to remind them that sometimes bad results are better than good results if they're telling you something you didn't know. The other side of it is watching a student develop and become an independent thinker and a confident scientist who, instead of waiting to be told by me what experiment they should try, they're trying those experiments and then coming and telling me what they did and what they think it means and what they plan to do next, and essentially relegating me to the role of a consultant instead of a direct supervisor. And by the time, most of my students are doctoral students, and by the time a student gets a PhD, in my opinion, that student should be quite self-sufficient and able to direct his or her own research. And so it's really exciting to me to watch that transformation take place and realize that when this student leaves my group and goes out into the world, I can write a letter of reference for them and say, this student, this now no longer student, this doctor, this PhD, if you hand this person a problem, they know how to solve it. And that's an important part of our job. Well, I don't know. I mean, I don't think you ever really become bored or blasé about these kinds of results. It's always a big blow to your not your confidence, but your overall positive outlook. And really, I think the important thing is to let it simmer for a day or two and maybe let your subconscious chew on the problem. And I find that after I acknowledge that we have a bad result, and I maybe discuss some contingency plans with my student, but we don't make any firm plans for a few days, and then we both kind of think about it and maybe try to draw up a list of priorities on what do we really want to accomplish in this project, and how has this bad result changed our chances of accomplishing those things. And well, first of all, I think they're extremely well trained, very dedicated, serious students, and when I discuss chemistry with them, it's clear that they already have quite a high knowledge of the field, and obviously when I watch their work habits, I see that they are extremely dedicated students. They work very hard. For my students, I make it clear to them when they join my group that I want them to go to multiple national or international meetings and have the chance to present their work, but also just to interact informally with other people. And I think the more you do that, it serves a number of purposes. Of course, there's an exchange of ideas that you get that's beyond the sort of cozy environment of your own lab. And sometimes people can make really good points that had never occurred to any of us. But also, I think it builds a lot of confidence in the students in terms of their ability to present themselves and present their science in an effective way, and maybe build up some networks of professional connections that could be useful at a later point in their career. It's unique in that it brings me here for almost a month and really immerses me into a single department's academic environment. So when I come to Japan for longer stays in the past, it's typically involved a lot of traveling, spending one day here, one day there, a lot of days on the train. Here I've more or less stayed in Sakai, and maybe I've made a few minor trips to companies or universities right here in the Kansai area, but every night I've stayed in the same apartment, and most days I come in to the chemistry department here, work in my office, interact with my host, with his students, and that's a really nice experience to have that much more in-depth interaction with a small group of people. So I've really enjoyed that from my own perspective. I think the students and the university, the larger university, benefit. I think I wish we had a program like this, is I guess how I would answer it, because when I think how our students would benefit from having somebody from the outside come in and maybe teach a short group of lectures on a few focused topics, and then informally also interact with our students, that would be a fantastic opportunity. We try to give our students the chance, for example, to spend a little bit of time when we have a seminar visitor. Maybe some of them will go out to lunch with the seminar visitor, or have a short meeting, but it's really a small group of students who are able to do that, and they do it for a few minutes. If we had a visitor for 3 weeks or 4 weeks who was in the department almost every day, I think our students would just really take advantage of that opportunity and spend a lot of time interacting informally with that person, as well as, of course, attending the lectures. So I would hope that students here are deriving some benefit from having somebody come in to the department and be there in case they want to come and talk, present a series of lectures and maybe a different perspective. I think every department in every country have a different way by which they teach. I mean, ultimately we all study the same topic, organic chemistry, but still the way in which we learn it or teach it is always going to be slightly different. It's nice to see it from a different perspective if you're a student. You may not necessarily learn anything you didn't know, but I think you'll still gain maybe a greater depth of understanding. And I certainly hope that the government continues this program, because and certainly from my own selfish perspective, it's been a great experience.